Welcome to today's video. I'm Renewable Energy Steve, and today I'll be exploring why solar, home batteries and heat pumps are technologies that complement each other really well. You may notice that people who get solar often go on to get home batteries and sometimes even heat pumps, and fairly frequently in that order. Well, here's why. Each of these technologies have a very specific purpose, and they're highly accomplished at achieving that. But they also have an obvious weakness. Let's start off by exploring solar. The purpose of solar is to create large quantities of energy over a time frame, and it's very effective at doing this. You might find a typical array is anything between 2 kilowatts peak and 7 kilowatts peak, depending on roof size. Now, the orientation, roof pitch, region and shade profile are all going to affect the amount of generation it can produce, but typically you could be looking at anywhere between 1,000 and 7,000 kilowatt hours annually. Now, solar as a technology does have obvious weaknesses. Firstly, there will be no generation during the nighttime. Any generation that's going to happen is going to happen during daylight hours only. But then you're going to have daily variance. So on a sunny day where you get completely direct sun the whole day, which those days are relatively rare, but when you get one of those lovely days, that can produce anything around about 10 times more than on a rainy day or when it's highly overcast. Then you've got seasonal variance. So the winter months, you're not going to be producing anywhere near as much as the summer months. In fact, the summer generation is likely going to outweigh the winter generation by a factor of 5 or 6, depending on the orientation. But that's just a rough guide. Now, with all this excess generation in the summer and probably not enough in the winter, how do we get around this problem? One method is to use a smart tariff. It's pretty important to be able to send any excess you might create back to the grid at a sensible price. Otherwise, you're just wasting all that hard-earned generation. There is another method, of course. It's going to cost a bit more money, but in the long run, it's going to be very, very helpful, and that is to buy a battery. This is going to help in all sorts of scenarios, so you'd be able to store up all that lovely solar power and use it at times when you need it. So for example, if the sun is shining during the day and then you come home from work and you want to cook dinner, but of course the sun has set at that point, of course that energy would be there in your home battery. A home battery can of course sustain any household loads up to a certain point while the sun isn't shining, so nighttime being a perfect example. But there's another way to get more out of a home battery, and that is once again a smart tariff. Yes, this smart tariff it's very much in the center of it all, because what that means is if you pick the right one, you can import at a very cheap night tariff and then export any non-needed energy at a time where you can get paid more, potentially more than what you paid for it, making you money in the meantime. So where do heat pumps fit into this? Of course, their purpose is to be an ultra-efficient heating solution, and they very much are. They're typically around about 4 times more efficient than a gas boiler, which is incredible. But I would say the weakness is that it still requires large amounts of electricity. Heating is a massive load in terms of whether you use gas or electricity to power it. It just requires a lot of energy for your typical household needs. And many would criticise heat pumps for not being able to get as hot as traditional gas boilers, which is true. But what you would do is you would simply run it for longer, and then the energy draw would be over a longer time frame. But with the weakness in mind of it just requiring really large quantities of energy, which can be very expensive, how do we address this? There's a few ways. Firstly, there is solar, and while it's not going to power the whole energy requirements that a heat pump would have throughout the day, it can at least contribute a proportion. But perhaps more effectively, there's battery storage, and obviously this has limits. The size of the battery in question, or batteries, is a key point here, depending on how much energy the heat pump is going to require throughout the day, but there's a good chance that a reasonable sized battery can contribute a very large amount of the heat pump's energy requirements throughout the day. And obviously, coupled with a smart tariff, you can get that energy nice and cheap, or of course from solar produced at a previous time frame. Then, of course, there's smart tariffs, which can relate directly to heat pumps. You can get ones where you have a long, cheap period. Octopus, for example, they do a special heat pump one called Cozy, where they've got cheap time frames, quite a few of them. I think there's 3 in that particular one, dotted throughout the day, so you can have your heat pump on during those cheap times. And yeah, obviously pay a lot less for your energy, and that makes the price of running the heat pump quite a lot cheaper. In contrast, if you were to have no solar, no battery, and no smart tariff in place, you'd find that the running costs of heat pumps would not be so attractive. In fact, they'd be very similar to running a gas boiler. And despite the efficiency difference, where it's maybe 4 times as much, that's cancelled out by the fact that electricity is close to 4 times the cost under normal circumstances as what gas is. Now, the heat pump itself doesn't actually contribute anything back towards solar or batteries themselves. It purely consumes the energy, which is why a lot of people they typically tend to get the heat pump as a last thing after perhaps the solar and the battery storage. But it's very much personal preference, depending on different households have different needs, and obviously heating is important. So there are some games to be found by getting a heat pump and getting a smart tariff to make the average electricity price as cheap as possible. There is, of course, one additional technology that I've not included today in this video, but very much fits in with solar and battery storage, and that's electric vehicles. But that's very much its own topic. So for now, that's it for this one. If you have enjoyed, be sure to press that like button, leave me a comment, let me know what you think. Do you have any of these technologies installed? Do you have a particular order you're thinking about doing things? That's it from me. Thank you very much for watching, and I'll see you soon.